So in this question, we're given a function, f of x, which is equal to ln of 2x minus 5 plus 2x squared minus 30. And we have the condition that x must be greater than 2.5. Question part A. So we're being asked to show that f of x equals 0 has a root alpha in the interval 3.5 to 4. So how are we going to do this? So what we can do is we can show that if there's a change in sign within the interval 3.5 and 4, then we know that there will be a root at f of x equals 0. Let's take f of 3.5, which is the start point of our interval. So what we do ln of 2 times 3.5 minus 5 plus 2 lots of 3.5 squared minus 30. So then if we put this into our calculator, it comes out at negative 4.81. So if we then take the end point of our interval, which recall is 4, we'll then have f of 4 is going to be equal to ln of 2 times 4 minus 5. So we're not going to write this out again, but we'll put this into our calculator, and it comes out that f of 4 is equal to 3.10. So we have negative 4.81 and positive 3.10. So therefore, in the interval, so we're working on the interval 3.5 to 4, we see a change in sign, and this means that there is a root within this interval, and we denote this root alpha, and therefore we have completed part A of the question. So now moving on to part B, we're given some further information. So we're told that a student takes 4 as the first approximation to the root alpha. So we're then given that f of 4 is equal to 3.099, and the derivative of this, we then plug 4 into that, and we have that f-4 is equal to 16.67. So in part B, we're asked to apply the Newton-Raphson procedure once to obtain a second approximation for alpha, and we're asked to give our answer to 3 significant figures. So our first thing to recall is, what is the Newton-Raphson formula? So you may remember that the Newton-Raphson formula is going to be x of n plus 1 is going to be equal to x of n, so our starting point, and we subtract f of x of n, and we divide that by f dash x of n. So this is important. This is the formula which we're going to use. So we then recall what information we're given. So we're given that xn is equal to 4. So this is our starting point. We're then given that f of 4 is equal to 3.099. And then f dash of 4 is equal to 16.67. So this then means we can take these values, which were given in the question, and substitute these into our formula to work out what x of n plus 1 is going to be equal to. So therefore, x of n plus 1 is going to be equal to 4, and then we take away 3.099, and we divide that by 16.67. And putting these numbers into our calculator, it comes out with 3.81409. Then there are some further decimal places, but that's all we're going to need to conclude the 3 significant figures. So then rounding this to three significant figures, we have that x of n plus 1 is going to be equal to 3.81. So now for part C. So what do we have here? So we're asked to show that alpha is the only root of f of x equals to 0. So this is a slightly trickier question. So to start off, we're going to set f of x equal to 0. So f of x equals 0. So then this means that ln of 2x minus 5 plus 2x squared minus 30 is going to be equal to 0. So what we can now do is we can rearrange this so we have each x term on either side of the equality. So this leaves us with ln of 2x minus 5 is going to be equal to 30 take away 2x squared. So this is now our equation that we want to work with. So we know that these two terms have to be equal. So what we can do is we can sketch the graphs of these two equations and then look and see at how many points of intersection there is. So now I've drawn some axes, we can take a look and have a think about how to sketch these things. So let's first take 30 minus 2x squared. So we know that this is going to be a parabola shape, and it's going to be a negative parabola because of the negative in front of the x term. And because we're only sketching the graph here, the exact specifics don't matter too much. So what we can do is we can draw in our parabola. So here we have, it'll take this sort of shape here. So that's a good starting point, and it's we can see the shape of our graph. So then we can now, I'm going to do this in green so we can see the difference. We can now draw in ln of 2x minus 5. So it's going to look something like this. It's going to increase up, cross the axis, and then turn like that. So now, what do we notice? Well, there's only one point of intersection between these two graphs. So what this means is that we can conclude that they meet in one place, so there's therefore one root. So we'll just write this down. One point of intersection. And what this means is that there is only going to be one root. So that means that alpha is the only root. And therefore we have finished the question. So now we're going to take a look back and see where the marks were on offer. So part A, where we had to show that there was a root in between 3.5 and 4. It was worth 2 marks. So we received our first mark for calculating f of 3.5 and f of 4. And then we received our second mark for knowing that a change in the sign results in there being a root in this interval. Then for part B, it was worth 2 marks also. So we receive our first mark for both knowing the Newton-Raphson formula and substituting our values in. So stating the formula, substituting our values in, that gives us 1 mark, and then we receive our second mark for concluding correctly that x of n plus 1 was equal to 3.81. We then move to question part C, which was worth 2 marks. So we receive our first mark for attempting to sketch both the drawings. So we receive that mark for our sketch here, and then we receive our second mark for our little conclusion where we stated about there only being one point of intersection, and that meaning alpha is the only root.